All right, so let's look at the second half of 4-1. Just to recap, if you're trying to determine if figures are congruent, they must have all corresponding angles are congruent and all corresponding sides are congruent. We're really starting to focus on congruent triangles, but they've thrown in some congruent figures in your homework as well as just plain triangles. So if we look at problem 3, is triangle ABD congruent to triangle CBD, and justify your answer. So if you look at the picture, what do you know from the picture? You mean side AB? Yeah, so I know that side AB is congruent to side DC. And we're going to call it CD. Why CD instead of DC? Because A and C technically would be corresponding if we know what their angle measures were. Alright, so we know that from the picture. There's one other thing we know from the picture. What else can you determine is congruent just by looking at the picture? Think of it in terms of this triangle versus this triangle. No, because we have no tick marks. So if there's no tick marks, you can't assume it. Eric? Which one? What about DB? It's the same side. Since both triangles share side DB, we can conclude that DB is congruent to DB. So there's no tick marks on that one, but the fact that they do share it means that they're congruent. And you're going to see that a lot. That's incredibly popular, and it's one that you'll tend to miss. So make sure you look for those shared sides. So then that's all that we can tell is congruent. You cannot make any assumptions that are not there. So to prove two triangles congruent, you have to show that all what are congruent? Corresponding parts are congruent. So circle the names for triangle ACD. Is triangle ACD an acute triangle, and ACD is the whole big outside triangle? Is this acute? What's the definition of an acute triangle? All interior angles are acute. So is that acute? Yep, is that acute? Look at this one. Can we make the assumption that this is a right angle here? No. Is there a right angle marker? Nope, so I can't make the assumption. It's definitely not obtuse. It might be acute. It's hard to tell. I'm going to make the assumption it's possibly acute, although it's a little iffy based upon that angle right there. But that angle is definitely, well, I mean, I guess it could be 91 degrees. Is it isosceles? What's the definition of an isosceles triangle? That two sides, at least two sides are congruent. So are there at least two sides congruent? Yeah. So it's isosceles. Is it a right triangle? No, we have no right angle marker, so I cannot make that determination, although that one looks like it possibly could be a right angle. Is it scaling? If it's isosceles, it can't be scaling, because scaling means that all three sides are unequal, different measures. So these are best, and this one is kind of iffy. Cross-allocate congruent statements that are not supported by the information. Well, we already know that these are the only two that are supported by the information in the picture, so we're going to cross out all of these. We can't support, those are all the corresponding parts. So out of the 6 corresponding parts, we can't prove 4 of them congruent. So we need 6 congruent statements to prove 2 triangles congruent. So are we able to prove the triangles congruent? Nope. So you cannot prove that they're congruent. You have to have 6. Alright, so then we come to theorem 4-1. This is going to be something that's going to help you prove an additional congruent statement without arc marks for angles. So you want to put this on a flashcard. It is called the third angle theorem. Your textbook will put that as a reason, third angle theorem, but you're not allowed to use the name third angle theorem. You have to write what it means. And so if 2 angles of one triangle, so you see this triangle ABC, there's 2 angles of one triangle are congruent to 2 angles of another triangle, then it stands to reason that the third angles must be congruent. For instance, If I put a degree measure here for B, I don't know, let's say that B is 30 degrees. Wouldn't that mean that E is 30 degrees? Right? And let's just say that A is 50 degrees. Not that I want that. How about 70? We'll go with 70 degrees. That means that B would have to be 70 degrees. What do you know about angle C? Angle C have to equal 80, and how do you know that? They all have to add up to 180 degrees by the sum angle theorem. So, what do you know about angle F? It has to also equal 80 degrees for the same reason for the sum angle theorem. They all have to add up to 180. So then your conclusion is that angle C must equal angle F. So this theorem comes in handy because if you were given this picture from the beginning, we could automatically jump to the conclusion that angle C must be congruent to angle F rather than go through that whole sum angle theorem. Because otherwise in a proof, we have to start with these two being given. Then you have to say that angle C is congruent to the measure of angle C is 80 degrees, and the measure of angle F is 80 degrees. Why? Because of the sum angle theorem. All the interior angles of a triangle have 180 degrees. You can say that. Then you could say that the measure of angle C is congruent to the measure of angle F, and so this just skips a step. Bless you. So on this one, so I didn't use their angle measures, but on this one, if the measure of angle A is 74, then doesn't B have to be 74? If B is 44, E would have to be 44, and if C was 62, then F would have to be 62 degrees. What do these three angles add up to? If you add them, they do indeed add up to 180 degrees, and so do those. Then we're going to do a little proof, and then I'm going to have you do a proof on your own. There we go. I can't quite get it all in there and not have it buzzed. See if I can get it unfuzzed. Nope, it's going to be a little fuzzy. Alright, so look what they gave you. They gave you that angle A is congruent to angle D, and so they put an arc mark there. If they had not put an arc mark, you'd be putting an arc mark on the picture. So you always mark up your picture with this. Then they said that side AE is congruent to side BC, so you have single tick marks there. Side EB is congruent to side CB, so we have double tick marks there. And then side BA is congruent to side BD, so BA and BD have triple marks there. How many pairs of corresponding parts have they named here? How many pairs? 4. 4 pairs. How many pairs do I need altogether to prove the triangle is congruent? 6. So I need 2 more. And that's what they want us to prove, is that the triangles are congruent. So just look at the picture. What else can I prove is congruent without any help? What can I see as congruent without knowing? Yes, but you can't call it angle B. Because when you say angle B, I don't know whether you're talking about this one or that one. So how do we name this angle correctly? We're not going to name it angle ABE. Yeah, so B has to be known. So angle ABE is congruent to angle CBD. Why? So I'm going to put double arc marks here. Aren't they vertical angles? Vertical angles are congruent. This is called pre-proof planning. So I'm planning my proof. I've got 4 pairs. I know I need 6 pairs congruent. All right, so what else do I have to prove congruent? Yeah, so I have to prove that this angle right here and this angle right here, E and C are congruent. Angle E is congruent to angle C. That's the only one that's left. How come I can say that? It's that third angle theorem, right? So I'm just going to put, for shorthand purposes, the third angle theorem. We're going to have to write it out in the proof. So that gives me my, this is the fourth pair, this is my fifth pair, and then this one gives me my sixth pair. So once I have my sixth pair, then boom, I can say the triangles are congruent. I can't say that until I have all six. So, you're given 4 parts of congruent parts. Circle the additional information you need to prove the triangles congruent. A third pair of congruent sides, is that what we needed? No, we did a second pair of congruent angles, and we did a third pair of congruent angles. So those are the 2 additional ones that we had to find. So flip this, bearing in mind that we still have, where we go, this, fold it. This is what we're looking at. Our picture would be really handy. Oh, there it goes. All right, so they've given you all the reasons. You have to come up with part of the statements here. So complete the steps of the proof. They put all the sides together in one given and all the angles in another given. It's not necessary to do that. If they just chose to do that, not fine. So just finish off what they gave you. AB, side AB is congruent to side BC. EB is congruent to side CB. And BA is congruent to side BD. Those are all sides that they gave you in the given. So we're just repeating those. And then they gave you one angle congruent statement, which was angle A is congruent to angle D. All of that was gotten from the given. Then remember that our very next thing that we chose to prove was the vertical angles were congruent. And so they start off with angle ABE. So we're going to put here angle DBC. And they've used vertical angles are congruent with series. And that's an acceptable thing to write. And so this gives me, right here, 3 pair. This is 1 pair. This is 1 pair. And now I've got my last pair. So angle E is congruent to angle C. So this is my last pair. So that makes 6 altogether. And the reason for my last pair I don't accept from this, so this we won't be able to write this way. So you're going to cross that out. And you're going to write with 2 angles of 1 triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So you can't write the third angles theorem, because I need to know that you know what it is. But you're allowed to use abbreviation symbols. So definitely write yourself a big note. You got to put that on a flashcard. If you don't know it up here in your head, you're not going to be able to write it on paper. This one's very easy to get messed up. Oops. All right, and so the last statement has to read exactly as the original proof statement that they gave you, which was right here. So if they said that angle AEB, triangle AEB is congruent to, you must use the same statement, BC. So once you hit those 6 pairs, that's why we could go to that triangle congruent statement. That's actually an error. Questions on that? We're going to do another proof in just a minute. All right, so before we do the proof, let's just finish out our notes. So underline the correct word to complete the sentence. To disprove a conjecture, you need 1, 2, or many counterexamples. 1, 2, or many. Just one. All it takes is 1 counterexample. Ian, can you get your head up off the desk? There you go. I want you to circle the equilateral triangles. An equilateral triangle has 3 congruent sides and 3 60-degree angles. So circle the ones that appear to be equilateral. You don't have any markings in there, so it's hard to tell for sure, but figure out which ones appear. So hopefully most of you circled these two. But this is also an answer. You've just completed an entire section on congruent figures, but they're not asking you about congruent figures. They're asking you specifically about just an equilateral triangle, right? Well, that's an equilateral triangle too. It's just not congruent to these two. And so your answer would be equilateral triangles have 3 congruent sides and 3 congruent angles. Not all equilateral triangles are congruent. All right, so then turn to page 220. Oh, no, don't turn. Never mind, because they give you the answers. So I'm going to cover up the answers. No turning in your book. Yes. Okay. All right, so I'm going to put the proof up here, and you're going to write it down. So you do need some paper, or, yeah, you need paper because you don't have a back to this. So grab a sheet of paper, and then you'll want to attach your notes to this. So here's our proof, and we may or may not do the proof exactly as the book does it, because there's more than one way to do a proof. So I want you to copy this part down. So I want you to copy the given, the prove, and the picture. So copy all of that down. Because at some point you're going to have to do a proof on your own. And so I want you to do some proof and because on this next test, your quiz, I will probably give you the statements and the reasons mixed up. You'll have some statements and some reasons, but you won't have all of them. So there will be blanks in them. By the time you take your test, you'll have the reasons and you'll have to come up with statements. And you'll probably have to put the reasons in the correct order. Given the improvement picture, and just mark it down so I can tell we're all in the same spot. And it'd be nice if you had a different colored pen to mark up your picture with so that it's clear. while you're waiting for everybody to finish, I want you to be thinking, what have they given you? What do you need to prove that those triangles are congruent? So do some pre-proof planning yourself. What have they given you? What do you need? And then once you figure out what you need, how can you do that? So in their given, they have given you 2 congruent sides and 2 sets of congruent angles. How many parts is that all together? 4. How many do we need all together to prove triangles congruent? 6. So we're missing a set of sides and a set of angles. So let's just start with the sides. What side is missing? LN. So what can you say about side LN? The 2 triangles share side LN, don't they? And what did we learn from the last proof that we just did? Yeah, but the reasoning we don't know, because, or it really wasn't the last proof that we did, it was that example that we had. You don't know the reason for this yet, but let's write it out and see if you can figure out the reason. If LN is congruent to LN, what does that look like? What property is that? It's not symmetrical. It's reflexive. It's a reflection. It's an exact reflection. So this would be the reflexive property of congruent segments. So when 2 triangles share a side, those 2 sides are equal. And that's going to be your reflexive property of congruent segments. So I don't expect your proof to be this nice, neat little thing. I expect to see this pre-proof planning written up there. So this is going to be our 5th piece that we need. So then we need one more. We need a 6th piece. Which angles are missing? At what vertex? There's only one angle vertex that isn't arced. N. So how are you going to name this angle right here correctly? LNM. So angle LNM is congruent to, or you could have said MNL, as long as N is in the middle, is congruent to this one, LNO. Why? So we're going to shorten that up just for our pre-proof planning. That's that 3rd angle theorem. Because you've got 2 angles here and 2 angles here that are congruent, it stands to reason logically that that 3rd angle must also be congruent. So then let's go ahead and prepare a proof. I personally would not split up my sides and my angles. I would just put the whole given into one statement. So me personally, I'm going to put the whole given in one statement. Side LM is congruent to side LO. Side MN is congruent to side ON. Angle M is congruent to angle O. How come I can name M and O just M and O, and I don't have to name it LMO, or I'm sorry, LMN? It's the only angle at angle M, right? So that's the reason why we can name it that way. And then angle MLN is congruent to angle OLN. Why? Given. Should always be your first reason. Then 2, go to your pre-proof planning. From here, what did we conclude? Right, so I concluded that one. So line LN is congruent to line LN. Our reason we've already written out, reflexive property of congruent segments. If it were angles, you'd say congruent angles. Then our third step was what came next. Angle L and M is congruent to angle L and O. We cannot use the third angle theorem as a reason. We have to actually state it out. So write it out. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So off here to the side I have 4 pairs, one pair for a total of 6. The minute I hit that 6th congruent pair, immediately my next statement is the triangle congruent statement. And because that's what I'm trying to prove, we're done. I'm going to move this down a little bit. Triangle LMN is congruent to triangle LON. Why? All pairs of corresponding angles and sides of both triangles are congruent. Something to that effect. So all corresponding sides and angles are congruent. I think your book is going to say definition of congruent triangles, but you have to write it out. All corresponding sides and angles are congruent in both triangles. Fairly straightforward, simple proof. Learn the progression. Yes.
So order of how you have the letters?
No. Here,
Yeah, you say,
it has to be exactly as the proof statement was. Since that's your proof statement, you have to list it exactly as it says.
but then you
Like here, yeah, you can have that and whatever. And you can have these switched around too. So these particular ones right here did not have to go in that order. You could have flipped them. And that's okay. So that's why your proof might look different. Well, let's go ahead and look at their proof. So you've got yours written down, correct? So let's look to see what their proof said. Let's unveil it. So they went ahead and split their given up as predicted. They put their angles and sides in 2 different givens. I don't find it necessary to do that. They did go from these congruent sides, so this is the 3rd congruent side, and they did say they were a reflexive property of congruent segments, should be. And then we kept that together, and then we listed out our third angles theorem. So the only thing that was different was they split out their given from us, but other than that, it's the exact same proof. So not all proofs are identical, but they have to have that general logical progression. Okay.